Yes.
Okay. Michael?
Yes.
Michael, did they get the answers to those questions which I sent last time?
Yes, I sent them the answers.
Okay. Is it worth picking up any that they were not sure about first? I mean, I'm not expecting them to get them all right yet, but were there some which they wanted to go through?
Yeah, I will discuss. I will discuss with them, and then I will give you feedback.
Okay, cool. Dan?
Yes.
Dan, I don't know if you can hear me, Dan. But at Tumaini, I'm hoping they got the answers to the questions last time. If they did, are there some of these questions which they particularly wanted to go through? I don't know if you can hear me, Dan. Tumaini, if you can hear me, can you just raise a hand? Great, thank you very much. Tumaini, did you go through these questions with the answers? Hi, Dan, can you hear me? Fatma's here. I think what I might do is just press ahead with what I was going to do as new stuff. Oh, hi, Michael.
In my side, they are saying they are okay. They are okay with the questions.
That's great. Yes. Okay. All right. Thank you very much. That's great.
Okay.
Okay. Let's just get rid of that. Okay, today, guys, hello, hi. We're going to start. I'm recording because Silver Spring aren't quite here yet, but we need to get on because it's getting a bit late. Hi. Oh, hi, is that Silver Spring there?
Yeah, that
cool.
is.
Lovely to see you. Great. So what I'm going to do is I'm just going to, I've got a different thing to do with you today. I want you to write some equations and predict. Quite a lot of the KCSE questions ask you to describe an observation. So here we go. So what we've got is I've got a sheet which I want to show you, and I'm going to ask you to try to write the equation and to predict what we get. Okay, so I'm just going to share my screen. Can you see that, Yestin? Practice equation. Great, okay. Okay, what I want you to do is we're going to try to do this particular experiment, okay? Now, let me show you how it goes to start with, okay? What I'm going to try and do is see if I can show you how this works. So if you remember from ionic equations, what it is asking you to do to start with, and it's very important that you do this. Whoops, hello. Wow, hang on. It will come back in a moment. Right, good. When you read a question, you have to highlight what you have to do so that you don't miss any points. Okay? So this is what we need to do. So the first thing I do, I'm going to do this first one as an example, and then you can look at the other ones yourself, and then we will do the practical. Okay, I will demonstrate the practical. Hi, Fatma, I can see the top of your head. So what I do is, if you remember, with ionic equations, what we do is we find all the AQs, okay? So identify AQs first, here, 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 okay? And all of the AQs we split into the ions, okay? So we split them into the ions, and then we can do something with it. Anything that is not AQ just becomes straight as it is, okay? So it doesn't change at all. So let me just write those down then. So HCl splits into H plus, oops, wrong, I don't want to go with that color, it's too much. Let me just get rid of that. So it goes to H plus and Cl minus. I'm sure you can do this. I just want to focus on something else. Na plus, OH minus, turns into Na plus, AQ, Cl minus, AQ, and because this is L, it does not break up, okay? So liquid, gas, solid do not split. Okay, so we end up with this. Then what I do is I look for the ones I can get rid of because they appear on both sides. So you can see this. I'm just going to do it fairly quickly, but I can see that this chloride here is here as well. So this is on both sides of the equation, so I can get rid of it, okay? I can just take out that chloride there, gone. I can take out that one, there. I can also see that I have Na plus here and Na plus here. Easy. So I can take those out. Which leaves me with the equation here, H plus, OH minus, whoops, becomes H2O. That's neutralization, okay? But now they're asking you to predict what you observe. So I have done my ionic equation, great, I have my mark for that. And now I have to work out what I'm going to observe. And in this one, they tell me that I have some indicator. Let me just get rid of the writing for a minute, okay? So I'm just going to get rid of this. We can see it again later, but that's not important. So this is recorded so you can see it. So what it says is I have phenolphthalein and excess alkali. In other words, my equation, which was H plus OH minus goes to H2O, is fine, and I won't see anything there, but they are telling me that there is more of this. This is in excess. And they are telling me that I have this indicator there, okay? So what I want to do now is to show you the practical, and we'll see if we're right, okay? So I'm just going to get rid of this. So I'm going to get rid of all of this, everything. Okay, what I'm going to ask you to do is to predict on 2 of them in just a moment. So I'm going to stop sharing that. I'll come back. Now, it doesn't matter if you didn't write out all that equation, okay? There will be all the answers at the end, okay? That's important. But what I want to do now is to show you what the practical is and see if we can predict. So we had, when we did the ionic equation, you get 1 or 2 marks for that. That's easy. We can do that. The second part, the prediction. It says I have phenolphthalein. We've come across phenolphthalein before. If you've been in these lessons before, we have come across phenolphthalein, the indicator, before. So what I'm going to do is I'm just going to show you the practical now, okay? I'm going to show you what happens. Let's see. What we're trying to do is to say what we would see, okay? Okay, so I have here a beaker, and what I'm going to do is I'm going to put some of the phenolphthalein into the beaker. Phenolphthalein is colorless. It has no color at all when it's neutral, okay? I'm now going to add the first chemical to it, which is hydrochloric acid. And your prediction should be, because you are meant to know the color of phenolphthalein, that no, we don't get any color in here. But then it says, add sodium hydroxide until it is in excess. Now, this is where the prediction comes. So here I have some sodium hydroxide. I will add it. And as I add it, at first nothing happens. And then, it goes pink. And it goes pink because in alkali, phenolphthalein is pink. Okay? All right. So let me just explain that. All right. So the idea is this. One, you have to write ionic equation. Number two, you have to predict, you have to say what I think I would observe. To do that, you have to go, okay, this is acid and alkali. It says excess alkali, so it won't just turn into water, it will be a solution containing alkali. Then you have to think, what color would phenolphthalein go in alkali? And the answer is pink. So you would say colorless liquid goes pink. Now what we're going to do now is I'm going to ask the three centers to do two equations each, okay? Here are the equations. I hope that your supervisors have these equations, but I will show you them now anyway, so you can see them. Okay. So here we go. What I want to happen is, if possible, is for Genesis to do number 2 and 3. Whoops. Come back up. Okay. I would like Genesis to do equation 2 and 3. Okay. So this is nitric acid, magnesium, magnesium nitrate, and hydrogen, and barium chloride, sulfuric acid, hydrochloric acid, barium sulfate. So Genesis, I would like you to do 2 and 3. Tumaini, I would like you to do 4 and 5. Number 4, this is sodium hydroxide, sulfuric acid, makes water and sodium sulfate. And they are telling you you have methyl orange, and at the end, there is excess acid. In other words, they are going to go past the point where it neutralizes to when it is acid. And this one here, hydrochloric acid, sodium carbonate, sodium chloride, water, carbon dioxide. And in each one of these that you do, you produce ionic equations. And then what you do is you try to predict what happens. I'm just going to reduce the size of this a little bit so that we can get everybody's equation on the screen. And Silver Spring, I would like you to do 6 and 7, okay? So we're going to have a moment where you just have a go. So the first two here are for Genesis, 2 and 3, 4 and 5 for Tumaini, and 6 and 7 for Silver Springs. What I'd like you to do first is just to turn them into ionic equations, okay? Ionic equations. So that means splitting up the AQs, but not the solids, okay? Just the AQs, not the solids. So there they are. I hope you can see them okay. And I'm just going to give you some minutes now in which I ask you to just do that, okay? Michael, Fatma, Dan, if there are problems that you can't see it properly or whatever, if you just tell me, I'll try and make it a bit bigger. I'll make it a bit bigger in a minute anyway. But if you can write down the basic equation, that would be very helpful. I hope you're having a go at this, Yestin.
I am.
Good.
I'm very excited about it.
Oh, yes.
How are you?
I'm all right, mate. How are you?
Oh, it's taken over.
Where are you?
I am in Drovers land. I'm in the land of the Drovers. I'm in Llandovery.
Yeah, no, I know, yes. Llandovery, yes. Yes, I remember it well, yes. Are you working there at the moment then?
I'm coming into the office maybe once or twice a week. And I've got to enter some figures which I can't do from home, so there's more reason for me to be here at the moment.
Right, but it's staying out of trouble at home.
It's well, it's getting away from home, coming to the office, doing a bit of work, and getting back. Yeah.
Yeah, I know the feeling. Let's find out if these guys have got this yet.
I've got my money manager system is here in the office, so and there's some stuff which I have people who need to do at home. So
I really want to catch up sometime properly about, people at Llandovery and so on, because I keep on thinking about it and then not doing anything about it. Anyway. Right, Genesis, have you turned number 2 and 3 into ionic equations? Genesis, thumbs up, thumbs down. Have you turned them into ionic equations? Sorry, I missed that. Michael, did you show me a thumbs up or thumbs down? Okay, good. So what we want now is, in a moment, we want you to predict what is happening in Genesis. Tumaini, number 4 and 5, you've disappeared. Oh, good. Okay, Silver Spring, because I can see Fatma. Oh, hang on. Let me just have a look at that. Hang on. Oh, pin. Hang on just a moment. I just need to pin that so I can see it. Very good. Well done. Now, we want predictions now, guys. Okay, we want predictions. So, Genesis, you've done 1 and 2. That was Silver Spring. That's great. I'm going to assume that Tumaini have also done it. Tumaini, have you done the ionic equations? Yes? Cool. Excellent. Excellent. Okay. All right, so now we need predictions. So Genesis, can you tell me what is going to happen in number 2? What am I going to observe in number 2? So that everybody can have a go at all of these equations, I am not going to get each center to go through it because I want each other center to do all of the questions, but we're going to do the prediction, okay? So, Genesis, could you get a microphone to somebody? I want to know what I am going to see in number 2, fairly quickly. What do you think I'm going to see in number 2? Nothing?
Excuse Teacher Mark.
Yes?
Could you please share the question so that
you want to see
can
the
see.
questions again?
Yes.
Okay, I'll share the questions again. Here they are. Can you see that okay, Dan?
Yeah, that's fine.
Excellent. Dan, you're at Tumaini, aren't you?
Yes, I'm at Tumaini.
So have they nearly done the equations 4 and 5?
Yes.
Okay. All right. Okay, I need somebody at Genesis to tell me what is going to be seen in this one. Genesis. Oh, Fatma at Silver Spring. Okay, let's go with Fatma. Fatma, oh, hello, that's sideways. I will try to see it. Let me just go bigger. Hang on, I'm just trying to see it, Fatma. It's very small for me. Oh, I'm going to have to stop sharing a minute, Dan. Fatma, try again. Okay, yes. Now, what are we going to see? Because what we want is, okay, yeah, that's good. That's very good. Yeah, I can see that, Fatma. That's good. Can you move it up just a little bit? Because I can see the top one, but not the second one. I can see it there. I can see it there. Okay, yes, good, excellent. Now let's see if we can predict. Okay, guys, let's predict. Here we go. So, Dan, have you seen the equations enough? Is that okay? I hope so. All right, maybe I will change my mind. Maybe I will show you it. Okay, I will show you the equations. So here we go. So in the first one, let me just do this here. In the first one, in Genesis, the first one, we have 2H plus MgS goes to Mg2 plus and H2. When you are predicting, ladies and gentlemen, listen please. When you are predicting, you are looking for, one, any change of state. So if it is all AQ, we want to spot, is there a gas? Is there a solid? Okay, those are the two most important ones. Is there a gas? Is there a solid? So in an equation like this one, what we should see is this. We should see this gas. Okay, so let me do the experiment for you and we'll see what happens. Okay, so I'm going to just do the experiment because it's important that you see what is actually happening. So here we go. So this is experiment 2. This is equation 2. So here we go. Okay, I'm moving to a different camera. And here I have hydrochloric acid. If you're asked what any solution looks like, unless it has a colored cation in it from transition metals, then we would expect it to look like this. In other words, just like water. Now I have some magnesium. This is magnesium ribbon. Magnesium comes in powder, in bits like this. This is called magnesium ribbon. And what I'm going to do is I'm just going to take this and I'm going to put it into the acid. Now, your prediction should say, okay, I've got hydrochloric acid. I know what that looks like water. I've got a metal that should be silver, okay? And I'm going to put it in. And because it says gas, what I should see is a gas, and you can see the fizzing. Now, if they asked you to do a test on that gas, hopefully you would know to do this. Here I have a flame. And that sound is hydrogen burning. That is a typical sound of hydrogen burning. Okay? So my observation would be fizzing. Okay, that's the big thing, that it fizzes. If it asks you for a test for hydrogen, we put our thumb over the top of the tube, then we get flame, like a match or a splint or something like that, and it burns, okay? That little sound is it burning. Okay. All right. So next one. Okay, in the second, in equation 3, hi Sophia. In equation 3, if we look at that, can anybody show me Genesis? Genesis, this is your question. Question 3, equation 3. Can you tell me what has changed in this one and what I would expect to see, please? Michael, can you get anybody from Genesis to tell me what we would see?
I am at another center.
Oh, sorry, I'm sorry. Who's
Yes.
at Genesis?
I've left a supervisor that is called
Okay.
in Gerard.
Gerald, can you tell me what you would see? Okay, so tell me what I would see. That's good, that's very good. But what would I actually see? Because your observation, guys, we have to be able to write down the observation, okay? The observation means I see, for instance, in that last one, I see bubbles, okay? In this one here, in the number 3, we get, if you look, BaSO4. Let's have a look at the experiment, okay? Let's have a look at the experiment because then you'll see what I mean by observation. So number 3, here we go. I'm going back to the other camera. It is important that you get these ideas. So here I have some barium chloride, okay? It's not very interesting. It just looks like water. Here is sulfuric acid. It looks like water. But if I look at the equation, it says S. If it says S, it means solid is produced. Well, that is what happens. There I get a white solid produced. If you were here last week, we did a yellow solid, which was lead iodide. The important thing is being able to describe what you would see. So for experiment 3, for equation 3, it says BaCl2, H2SO4, HCl, BaSO4. But 3 of them are AQ and 1 of them is solid. And this is it, okay? So this is what we are trying to do. We are trying to predict what we would actually see. The equation is one thing. You get 1 mark for the equation and another one for the observation. Quite often they ask for the observation. Tumaini, you did number 4 and 5. I hope you managed to do 4 and 5. The equations. Is there anything you can predict about what is happening in 4 and 5? 4 and 5. Tumaini? Have you done the equation? Okay. Tumaini, I can see you. You can see me. Okay. All right. Can you tell me what the equation is or what you would say everybody sees? Can anybody tell me at Tumaini what you would see? This is good. That is a very good equation. Hang on, let me just see if I can make that bigger. Just hold it still a moment, please. Good. And the second one? Just move it across. Okay, what is your prediction for the second one? Your first one is absolutely great. That's really good. Okay, what they said was that they would see, hang on, the pin has not gone. That's a bit annoying. So let's just have a look. Here's the equation. Here's the equation. What they are saying is because they have written the equation and it's just OH minus, H plus makes water. Because they are all either invisible like water or AQ, they will look like water. But we have indicator methyl orange and excess acid is added. And they said it would go pink. Let us just see if they are right, okay? So there they are predicting that. So let us see. Ah, come on. I can't get rid of. Okay, here we are. So the next one, it includes the chemicals are here. Here I have sodium hydroxide. You need to know that methyl orange, we came across methyl orange last time, okay? Methyl orange, when it's added to the sodium hydroxide, is an orangey yellow color. Some of the papers say yellow, some say orange. Let me just put it on a white background. It will be easier to see. Now I'm going to add the acid. And the acid at first, when I add just a small amount, makes no real difference, okay? That's because at the moment, it is excess sodium hydroxide. As I add more and more acid, though, it neutralizes it. And then when it is excess acid, it makes it the pink color. So Tumaini, well done indeed. That was very, very good indeed. Their second experiment, their second equation, so I'll just get rid of that one. Their second equation was about hydrochloric acid and sodium carbonate. This is hydrochloric acid, and this is sodium carbonate. Now, they both look like water. Once again, this is observation. But from the equation, we can see this will become salt and water and carbon dioxide. Let me try and get a little bit closer. So these will produce salt, sodium chloride, water, and carbon dioxide. So what you should say is, oh yes, if it makes carbon dioxide, I should see fizzing. Okay, so I add it, and there it is. And that gas, if I get a flame, and I put it near this, it goes out really quickly. And it goes out really quickly because that is carbon dioxide used in fire extinguishers. It is very dense carbon dioxide. So the carbon dioxide fills up the beaker, and when I take the flame, it stays in there, it does not come out. So it will keep on putting out the flame. So when you come to a fire and you want to put it out, what you do is you jet the fire extinguisher at the bottom of the flame. Okay, coming back to me. All right, the next one, 6 and 7 is Silver Spring. Does anybody in Silver Spring want to, oh, hello, why is Dan there? Okay, Silver Spring. You have done the equation, I know. Can you do the prediction of what you're going to see? Can you do the prediction of what you might see there? Because it's quite important. Silver Spring, did anybody try a prediction of what you were going to see? This is quite a complicated prediction, this one. It's quite important, so, and it is something that has come up before, so let us have a look at it. Does anybody in Silver Spring have an idea of what we might be able to see? Silver Spring are being very, very polite and very quiet. Okay, all right, well, I shall do it then. If you look at number 6, let us all just very quickly look at number 6. Here is number 6. Okay, if we look at number 6, I'm sure you can all do the equation. I'm sure you can all do the equation here. Look, this is going to look like water. That is water. We have carbon dioxide. This is going to fizz, but this time there is something different. And what is different is this. It has copper in it. And copper is a transition metal, and transition metals are colored. So Cu will be colored, CuCO3 will be colored, and CuSO4 will be colored. Let us just see what happens. So what I'm going to do is I'm going to go and show you that one so you can see it happen, because it's important. We have seen as many as we can. So in this one, I will get another beaker. Here, this is here. I hope you can see this okay. This is the sulfuric acid. Sulfuric acid looks just ordinary like water. If I put it on a white background again, you can see better that it just looks like water. But copper carbonate looks very different. Any transition metal, any of the metals in the middle of the periodic table, their compounds are usually colored, okay? So their compounds are colored. This one is colored. And this will go into here. When it goes in, it will produce a gas because it has a gas, so we will be able to see the gas. And something else will happen as well. So as I start to add it, we start to get a gas. The gas, again, is carbon dioxide. So if I take a flame, here it stays alight, but here it goes out. And what's happening this time is that we've got a slight change in color. And as we let the reaction continue, the green color disappears a bit. And it disappears because the copper carbonate is dissolving and it's making copper sulfate. And copper sulfate is not green. This is the original green. It's more green than this solution is. And the solution is going blue. And the reason it's going blue is because copper sulfate is blue. Okay. The last one, the last equation here. Here's the last equation. Silver nitrate. Silver nitrate, when dissolved in water, is colorless. Sodium salts in water are colorless. Sodium nitrate is colorless. And Silver Spring did this correctly. They said, okay, what's going to happen is this. It is basically going to be, this is going to split into Ag plus and NO3 minus because it's AQ, and Na plus and I minus turn into Na plus and NO3 minus, and this does not split up, AgI, and it's solid. This means that then I can get rid of the ones which are on both sides. Here, that I can get rid of because they are common ions to both sides. I can also get rid, I'll just get rid of those. So that has gone, okay. Then I can get rid of this because there it is on both sides. So I'll get rid of that. And I end up with this equation. So Ag, and it's AgAQ, and IAQ turns into solid. Now that is very important. What is important is that this is a test for halides. So sodium chloride, sodium bromide, sodium iodide, they all precipitate. The word for this solid is, and I'm sure you know this, is precipitate, suddenly shortened to PPT. That is okay in an exam if you have once written precipitate. If you write precipitate, PPT, then you can use PPT again, okay? So this is a precipitate. So what we should see is a solid forming. So let's go and have a look at that. All right, let's just check that. So I'll stop sharing and we're back to this. I'll just move all of this because this is all finished. You can see the blue color now. There's the blue color of copper sulfate from the last one. This is the green solid that we started with. We end up with a blue solution, okay? You're meant to know the color of copper in solution. And my last one is this here. And here I have the two solutions. So these are the two solutions which we had there. And what we're interested in is what happens, what color the precipitate is. So I'm going to add them together. Ah, okay. It has gone yellow. It has gone yellow and it is not transparent anymore. That you can see there's a solid at the bottom of it. Okay, it is starting to settle out. That solid is silver iodide. Now, silver chloride is white, silver bromide is creamy colored, and silver iodide is yellow. Okay, so that's really important to remember that one. All right, coming back to me. Okay, so hopefully now you have an idea of the things which you should be looking for. I'm just going to list them on the board now, okay? I'm going to list the things which we should be able to observe. So first, this is observations. Number one, what you must do to start with is to look at the reactants. So you describe them. You look and you say, is it a solid, is it a liquid, is it a gas? With the one with magnesium, the magnesium was a piece of ribbon. That doesn't matter. It doesn't matter that it's a piece of ribbon. It matters that it's a solid. So you are saying, I start with a solid and I add it to a solution. Okay, that's the important thing. So in that equation, that one with the magnesium, we would say, okay, I start with acid. Acid always looks like water, and a solid goes into it. Then the other thing that I look for is colors. The color is normally to do with whether it is a transition metal, okay? So transition metals are normally colored. So their compounds are colored. And if you are guessing at a color, guess at blue or green, because copper, iron, normally blue or green, okay? They're the ones which KCSE ask more about. So that's the reactants, okay? Then second, I look at the products. And the thing to remember is this, they're asking for an observation, not a test. So they're asking you to say what you can actually see. So, is it a gas? If it is a gas, then you can't say hydrogen. I can't see hydrogen. I can see bubbles. Yes. If it bubbles a lot, you probably know effervescence. It effervesces. That's fine. That's great. Bubbles, effervescence, yes. Hydrogen, carbon dioxide, no. We don't want the name of the chemical because we can't see it. I'm breathing out carbon dioxide, but I can't see it. Okay, if I boiled it into water, I would see the bubbles. So that's what we're looking for. Liquid, we almost never see anything. Solid, precipitate. Now, a precipitate, you can say I see a precipitate, but it's better to say it goes cloudy. Cloudy means I can't see through it anymore. If you say it goes opaque or something like that, that's fine, but cloudy is good. Like gas, bubbles, precipitate, solid, it goes cloudy. The last thing is it colored? And again, the same thing is true as the last one. If it is color, we're talking about transition metal. And basically, it goes like this. I'll move on to the other board. The colors that we normally see are these. Cu2 plus, AQ, blue. Okay? Cu2 plus, AQ, is blue. Fe2 plus AQ is blue. Sorry, no, it isn't. It's greeny blue. I want you to describe it as green. And Fe3 plus, this is rust colored, so we call it orange. All of group 1, group 2, group 3, not colored. Okay, group 1, group 2, group 3, not colored at all. So you wouldn't see anything like that. Okay? So those are the observations. This is what we expect you to write for observations. Look at the reactants, look at the products, and see if you can predict. So I'm now going to show you one that I'm going to show you just here, okay? I'm not going to show you the practical, I'm just going to do it as though I have the question to do, okay? And what I'm going to do is, okay, I start with CuSO4AQ, and I add BaCl2AQ, and it goes to CuCl2AQ and BaSO4S. Okay, so what I'm going to do is sorry, I'm just going to let somebody in. What I'm going to do is I'm going to turn that into an ionic equation. You can try at the same time. And then I'm going to look at what I would be able to see, okay? All right, so here we go. So I'm just going to get rid of this line here. So I turn it into an ionic equation. A2 minus Ba2 plus 2Cl minus turns into Cu2 plus and 2Cl minus and BaSO4 solid. Now what I do is I try to predict what I'm going to see. So I look at my little rules and I go, okay, I don't know what's going to happen. So I'm just going to get rid of these. Remember what I said.
Excuse me, Mr.
Hello?
The students go slowly.
Want me to go slower? I can put those back up in a minute. I'll put those back up in a minute, okay? Okay. So I look at my equation. I get rid of the bits which are just a part of the whole thing. So the chloride here is common. So I get rid of this, there, here. That's it. Okay? Oh, copper I can get rid of. Now, what I do is I look at my reactants here and I say AQ, AQ. So they're going to be transparent, they're going to be solution. But this is copper, Cu2 plus. So this is a blue solution. So I start with a blue solution because it is Cu2 plus AQ. And I add this to it. Okay? This looks like water. When it goes in, it forms copper chloride. That is still blue. But this is a solid. So it will very quickly change from blue solution to solid. And that's what we have to do for the observations. I will write down the things to look for again in just a moment. Okay, but that's what we do. We look at the beginning and the end. We say, okay, copper sulfate, that's blue. Barium chloride, colorless. Okay, copper chloride is blue because all copper in water is blue. And then the solid here. The solid means I see it go cloudy. That's the big thing, okay? That's the biggest thing that we can note. I'll just note down those things that I rubbed out. All right, but this is it. Blue, colorless, blue, solid. So every time you just look, what is happening? Colorless, colorless, gas, or solid, or whatever it is. That's the observation. Okay, I'm going to get rid of this. It is recorded and I will send the recording to all of you. But I will just go through those things to look for again. So the big things to look for are in the reactants, these guys, is it a gas? Is it a liquid? Is it a solid? Okay? The second thing is here, those things there. Are there any colors? So the colors normally come from things like Cu2 plus is blue. Then I look at the products. And again, I look for gas, liquid, solid. And what I said was important was that we can't see hydrogen or carbon dioxide, but what we can say is we can see bubbles. Okay, we cannot see hydrogen carbon dioxide. We can see bubbles. We can say effervescence. Liquid, well, I'm not going to see anything. Solid, it goes cloudy. Okay, it goes cloudy. And there are some precipitates which you need to know the colors of, but most of them you don't. And the colors matter in this as well. So colors are also important in the products. So the products here, this Cu in water, always blue. So this is blue, this is colorless, this is blue, this is solid. So I would see some blue, add some colorless, it stays blue, but it goes cloudy. So it is about turning it into a sentence inside your head. What is happening? What happens as I go across this here? Okay, so hopefully, have you got that okay? Silver Spring, are you okay? Okay, good. Thank you. Tumaini, are you okay? Excellent. And Genesis, you okay? Oh, not quite. Is that not quite because I don't understand it, or is it because I haven't quite finished? Genesis, is it not understanding? Not understanding. Okay. I will give two more examples. Okay. I will give two more examples where we can predict what is happening. I will just invent. I will do it on my screen. Okay, let us try something completely different as an equation. Let's see if you can do this one. I will write out one. This is what we call a replacement or displacement equation. What is happening here is I have some copper sulfate, CuSO4, dissolved in water, okay? And I'm going to add to it, sorry, that's a bit small. I'm going to add to it some zinc. Now, zinc is a more reactive metal than copper. You know that. So the zinc takes the sulfate away, ZnSO4, AQ, and kicks out the copper. Okay? Just turn that into an ionic equation, please. Okay, see if you can turn that into an ionic equation. Get off.
They're all working. Probably looking right, aren't they?
Okay. Tumaini, done? Yes. Tumaini, yeah. Good, excellent. Genesis, done? Okay. Simple, quite simple. Okay, let's look. So this splits Cu2 plus, AQ, SO4, 2 minus, AQ. This doesn't split, can't split. Zn, solid, goes to this splits AQ, Zn2 plus, AQ, and SO4, whoops, 2 minus, AQ, and Cu, solid. I can get rid of the sulfate here, because the sulfate is here and here, okay? But I can't get rid of anything else, that's all. Because this is different from that, obviously. So I have this equation. Now, to predict, what I do is, I said I look for gas, liquid, solid, okay. So this here, sorry. This here, Cu in water, okay? So in water, so that would, it might look like this, but actually, Cu in water, Cu2 plus in water is this color, okay? So this is Cu2 plus in water. So this is blue and its solution. Plus, what would zinc look like? Well, zinc is a metal, so it might look like my magnesium, yeah? Might look exactly the same sort of thing. So its metals are normally shiny, silver, solid, gray, solid. Zn2 plus in water is colorless. Don't worry about knowing that, but the only colored ones which I have seen in KCSE is copper and iron, okay? So zinc, this is a colorless solution. And copper as a solid, it is a variety of colors. It is often a pink or red or orange solid. Now, so what I have is now I can explain my observations. I can go, I start with a blue solution, okay? I add to it a solid, a gray silver solid, okay? It should turn into a colorless solution and this red orangey solid, okay? Have I got enough? I haven't got any zinc, but I can do something like that. This is not exactly this one because I don't have zinc, but I have some magnesium. So if I take the magnesium and I put it inside, what happens at first is I'm just switching it round. I don't know if you can see, but the color is getting less. It is becoming less colored because the magnesium, which is produced, the magnesium, I said zinc, I've got magnesium here, it's the same. The magnesium sulfate is not as colored as the blue color. Here's the original blue color. This is the new one, it's getting lighter. That's because that is not as interesting. The The magnesium sulfate is not blue, it is colorless. Keep reacting. It is reacting. I will just see if I can show you it in the other camera, because in the other camera, you will be able to see something on the magnesium which is forming. Let's have a look. Let's see if we can see it. It's not very easy to see, but I hope you can see that the magnesium doesn't look like magnesium anymore. It's gone red. And it's gone red because it is now copper which is being formed in there. They are taking the place. So the magnesium is reacting and going into the solution. There's the blue that it is now. This is the blue it was before. There's not a lot of difference, but this is a little bit lighter, and it will continue to go lighter and lighter until all the copper has gone, because the copper is in here as a solid now. So they have swapped over. So my prediction works. Okay? So that's the idea. The idea is to try and predict them. Okay. All right. So what we're going to do next time is I've sent now some other questions, more complicated questions about acids, bases, salts. I've sent them to your supervisors, and they are all standard KCSE questions. Okay, they're all observations. Okay, observation ones, and we will do that for half of next time. But I would like you to tell me what else you would like me to do for next time. Okay, so next time, next week, we will do this other sheet, and then we will do something else. To my guy at the front going, please don't do anything. I've had enough. I've had too much. I can't do any more chemistry. Chemistry's too hard. No, it's not. No, it's not. It's really difficult if you don't have a laboratory and do it, okay? But it isn't too hard for you. You can do it. Yes, you can. Okay. I thought I'd show you one thing at the end. This is something that we do sometimes. I'll just show you on the other camera. I want to show you how we do one peculiar thing. This is 3 tubes, okay? And these 3 tubes, all I'm going to do is I'm going to add the same chemical to each one of them, and we're going to see what happens. All I did was to add sodium hydroxide, alkali, to 3 different chemicals, and it went red, white, and blue. Okay? These are my national colors. Red, white, and blue. Sorry, yes then. Red, white, and blue. Okay, I should put a green in. The question is, what could these be for sodium hydroxide to do this? I'll tell you. This was phenolphthalein. Phenolphthalein goes pink in alkali. This one here, this is a precipitate. You can see it's a solid in it. Yes, you can see very clearly, very solid. Okay, that's magnesium. You need to know that magnesium hydroxide is not soluble. And this was universal indicator. So I could add the same colorless chemical to all of them, and I get red, white, and blue. Okay, it is time to finish, because I have to go and teach my own classes now on this Wednesday. But I hope that you have got an idea. Firstly, you can do ionic equations. That's really good. That's really important. Second thing, I hope you understand what you can think about when you are trying to predict blue solution, colorless solution, precipitate, solid, okay? Bubbles, that sort of thing. If you can do that, you are doing really well. So next time, your supervisors will have some sheets which they can give you to have a look at. They are further chemistry with this. And then if you don't tell me anything else, I will do solubility, because that comes up a lot, solubility and precipitation and that sort of thing. But if you tell your supervisors what you would like me to do, I'll do it. Okay? Okay, thank you for your patience. I really appreciate your patience. You are very, very good students, and I mean it. So, but I'll say bye-bye for now.